Hello. How's it going? Had a good coffee break? Good. So, if you look at the list of speakers, you probably saw that this guy works at nowhere, and then you see, oh, the guy who made Cycle.js. Oh, that guy. Oh no. I hope he doesn't talk about like horses or something like that. Okay, but to me, React is just another web framework with a weird license. But React Native, seriously, React Native, in my opinion, is a game changer with a weird license. And actually, Yanni and I used to work at the same company back in 2015 or something like that. And when React Native came out, I was like, man, this is really promising. And I basically looked at it and thought, by the end of 2016, this is probably going to be a serious contender to native development. And I think that's been, quite true, actually, if you look at today. And React Native, in my opinion, is not about React, but about the whole JavaScript ecosystem sort of changing mobile development. And I used to do native Java development for Android as a professional. And I know that this is way better, and I totally would choose it. I think React Native is a way that we can reboot UI development from scratch, using the best from web and the best from native. So I also, help bring like React Native to other stuff. Like I wrote the first commits for React Native Elm, so you could use that functional language with React Native. And I wrote this package called React Native Node, which basically allows you to run a real Node.js process in your app. So that is pretty cool because then you can run like FS, HTTP, dgram, all this kind of stuff. And in my case, it was like really necessary. Actually, it deserves a separate talk. I don't know, maybe one day I could do that because it has many use cases. So the app that I'm building at the moment is a React Native app. So what is this talk going to be about? Is actually a little bit about Cycle.js. And it's not about competing frameworks, actually. I believe the title should have been React Native and Cycle.js become friends. You won't believe what happened next. And I found this from some website on the internet. Yeah, there's some other articles as well there. What's so funny? Okay. So I'm going to explain some stuff that's probably going to feel, like intense JavaScript fatigue. So I don't want you to feel that stuff. I don't want you to feel burdened and, oh no, I need to learn this stuff. So I just want to propose something simple, okay? Don't take it seriously. Like, I don't take myself seriously, so neither should you. So just watch this talk out of curiosity, okay? Just like as an interesting exploration of different ideas, okay? No big pressure to actually learn and actually use it. The overview of the talk is React Native development is architecturally more challenging than React web development. Then React is nice and declarative, but the native APIs that we use are often simply not declarative. How do we manage those native APIs? How do we do that in terms of architecture? And then I'm going to show a little bit of the ideas how Cycle.js handles that together with React Native, and then a real-world example app. So why is React Native harder? Well, basically because this is really new stuff, and we are all pioneers here, so we really don't know what we're doing. I mean, I don't know what I'm doing, and that's exciting. And also, it's polyglot development. So if you're doing web, you use JavaScript and HTML, CSS. But if you're doing Android, you're using Java, iOS using Objective-C. In our case, we're using all of those languages. Plus, who knows, C if you need to debug some kind of yoga or whatnot. And there's Flow and there's TypeScript and maybe Swift and Kotlin. I mean, this is really, really more broad. And there's more challenges than just rendering in state and some other stuff. So for instance, React solves rendering, Redux solves state management, and you have some routers that solve routing, and what else you have? Maybe requests, maybe something like GraphQL. But you basically, most of the time, you're concerning yourself with rendering, state, routing, requests. And with React Native, we know that we have all of those, plus many more dimensions. So it's just more stuff to handle. And then you're never sure if you should make that question on GitHub or should make it on Stack Overflow. So that's kind of adds to the challenge. So React is declarative, and that's nice. And if you have explained to your boss why should you use React Native, you probably said something along the lines of, you know, in React Native the rendering is declarative, you don't need to manually update the parts of the UI, that's like the opposite of what we do in native. And that's true, and that's one of the reasons why most of us bet on React Native. But on the other hand, you have other APIs like, you know, this one that has a show method, which is imperative, and then you have also this vibration API. You say, you know, start and stop. That's imperative, and you pretty much need to manually update that state, right? And then you have toasts for Android, and you know, toasts are actually 100% UI. They're not like any kind of other thing. They're actually visual, they're UI. But still, we're declaring it in a very, I mean, we're using it in a very imperative fashion. We're not using it kind of like we do with rectangles on the screen. We also have the clipboard, you have get and set, and then non-official APIs on NPM follow the same style. Here's a package for text-to-speech on Android, and there you have an imperative function speak, and you also have is speaking, and you have also cancel method. So basically, no, these APIs are not declarative, and this is how, guys, this is how UI development was before React came around, and we're doing it. So that's kind of funny. So the first insight, let's just try to settle this, that, you know, these are singletons that we're dealing with, like vibration.vibrate, and they have imperative methods. Let's keep this in mind. We're going to come back to it later. And how do we handle these kind of things? Well, the basic way is that we put it in like a lifecycle hook. So for instance, here, when component mounts, you know, it checks something and it calls the imperative method on the singleton. Another way would be in some action creator function. There we, you know, log out from some singletons inside this function. And these are all valid options, you know, things work, and, you know, apps get built and they get shipped. But could we do better? I mean, could we handle this in the modern style, not the style pre-React, you know, before React came around? So that's our other insight, is that, you know, components are not singletons, right? They have many instances, and action creators, you know, there are many instances of those, and like we called that many times. There are many actions, so these things are not singletons. So if you put these two insights together, that, you know, the native APIs are singletons, but the components are not singletons, then that means that we don't get composability, because you're calling something singleton from something that's not singleton. Now, what do I mean with composability? I don't want to give a very theoretical definition, so I'll just give you the composability test. And it's pretty simple. So you can just get that file that has the component, you can put it in a repo, and you can publish it on NPM. And it's going to be useful for anyone who imports it, okay? So that's kind of what it means to be composable. And for instance, in this case here, we have an app, and we have the hierarchy of components. We also have some custom singletons, such as my app manager, which is specific to your app. And we have the vibration singleton. And there, deep inside the hierarchy, you have some kind of call, such as my button, you know, will call vibrate on a lifecycle hook. So let's say the welcome tab, we cannot get that and simply put it on NPM because it's going to be tied directly to that my app manager. So you can't just do that. So it's not composable, that component over there. So what can we do? For composability, we need to call those red calls just from singletons. Okay, so singletons should be called from singletons. So how can we do that in practice? So we can take, for instance, all of these calls deep in the hierarchy, and we can put it above in a singleton. Okay. So now the welcome tab doesn't directly call the my app manager anymore, but so I can take the welcome tab, I can put it in a repo, and I can publish it to NPM. Okay, but how does the welcome tab actually call that API? How does it do that? So one option is that you can do it kind of like Redux does. Okay, so Redux introduced the singleton store, right? In Flux, we used to have multiple stores, but in Redux, you know, we have a singleton. And that singleton has dispatch. And the dispatch is passed down as a prop through this hierarchy. And that's how we can sort of like, we could pass the method of these singletons down as props and call that. We could, but if you think about it, you know, we learned about UI Manager today. and how it's called in the background for us. And we are not really calling UI manager create view from our lifecycle hooks, right? So, because there's a framework that handles that for us, and we don't need to deal with those things. So instead of doing that, we're going to do something a bit closer to how React manages views. So we're going to do this. We're going to basically bubble up an event from the My button as a request. I want to call vibrate. Okay, I'm going to do that animation again if you wanted, because it's kind of like fire. See, yeah, it bubbles up, and then the singleton catches that and actually performs the request. So this is like roughly what Cycle.js does. You can ignore for now exactly how does it do that. Just imagine that we have a way to handle this, okay? And it's pretty simple. And we call that singleton there, we call it a driver. And it just basically picks the events from your application and executes those events for real, okay? Everything red above is what we call effects. Basically real function calls that do real things. And everything green is just your application logic, how to compose those pieces together and make your app. So what happens when you do this? You get some interesting benefits. Of course, the first one that we talked about was composability. You can get those green boxes and put them on NPM. The other one interesting is interception. So basically, components can intercept an event which is bubbling up and sort of modify them or cancel them. For instance, let's say that my button wants to call vibrate, so it bubbles up the request, but my app component says like, no, sorry, here you're not going to call vibrations in this app because we disabled it. And then we're able to do that. Another benefit is testability, because when testing, I could just create a test singleton that doesn't run on the native side at all. It just runs on the JavaScript side that picks up all of these events that are happening in the green side and just makes assertions on them. And it doesn't actually like run anything. It's sort of totally headless, you could say, without an emulator or a device. And my favorite one is the bottom-up design. And that means that you can build a leaf component first, and then proceed to build the component after it, and so forth. And when you're doing that, you don't go back to the leaf and alter it. So the really cool thing about bottom-up design is that you don't need to do upfront architecture design. You just, because the sort of our comfort zone is when we're programming that, button, that special button, and only the button, right? So that's nice if we can start from those basic stuff and build upwards. So then the leaf component can assume that I will get everything that I need. So in order to explain bottom-up design, let me just explain to you a little bit about fractals. And I'm actually talking about fractals in Rio math. They are sort of pretty cool structures. They're basically recursive geometric figures, okay? So the way that you create the child figure is by copy-pasting the parent figure, resizing it, and putting it in the corner. And then you create this sort of infinite zooming geometric figure. And notice that the equal signs there, it works in both directions because equal signs. So it means that the way that I can create a new parent is by using the same pattern to create the child, okay? And that's pretty cool. And I'm going to show you a transition that I took a while to make for my slides. So please try to appreciate it, okay? And pay attention because it's pretty cool. See, I'm creating a new parent, and I just copied the child. So why am I explaining this? The idea is that in UI development, a fractal architecture would mean one where the components, the pattern used to build a leaf component is the same pattern used to build the root component. And it all looks kind of the same. And actually, if you use React with state and props, sort of the vanilla style, then you're actually doing a fractal architecture. Let's go back. And that's kind of also the property that governs the hierarchy of Cycle.js components. The pattern used here is the same as the pattern used there. And what is that pattern? It's data falls through this hierarchy, and requests bubble up. Okay, requests to call the actual native APIs. So this diagram is kind of pretty. I like it, but I'm going to make it uglier. So bear with me, okay? I want all of the arrows to go down, because right now I have arrows going down and arrows going up. Okay, so data is kind of falling down and bubbling up. I I also made it, this transition was harder to make, okay? So please try to appreciate it. And it makes sense, okay? Here we go. Cool, huh? I can actually do that again, sorry. Let's see. No. So this diagram is actually exactly the same thing as before. It's just if you think of it like this, you know, and you fold it back like this, it's the same diagram as before. So now, you know, we have data going down and sort of data bubbling down, you see. And I also have a weirder transition coming up, so I'm just going to rotate stuff, okay? Simple rotation. Okay, here we go. Ugh. Okay, this is the same thing as before. It's just that instead of wrapping around through the top, I just, you know, doing a loop. So we have unidirectional data flow in a loop. So it's kind of like a cycle, and that's Cycle.js, and now you kind of know Cycle.js. Kind of. Okay, but how does it actually work? Okay, I'm just showing figures here, but what about code? Okay. In code, one of those green boxes would be a function. It's not a React component anymore. And it takes stuff from above, and it returns stuff below. Okay? So the input is actually not an object. Okay? Typically, with React function components, you have like props as an object, as input, and you know, React element as an object, as an output. Here we have sort of like all of the props that happen over time, from now into eternity, and we have the output is all of the rendering that happens now and in the future. It's not an object that's just, you know, momentary. So that actually, for real, it means a stream or an observable and an event stream. So our component now is just a function that goes from a stream to a stream, and I'd like you to admire that for now because I'm going to make it uglier. Okay, that was enough time. So it's actually a function that goes from many streams to many streams. Why many streams? Because I need to do many renderings over time from now into eternity, but I also need to do many fetch requests over time. And I also may need to do many alert iOS requests over time, right? And when it comes to the inputs, I have many props over time, right, arriving to my component, but I also may have many hardware back press events over time, okay? So it's a function from many streams to many streams, because your component may handle not only props and rendering, but also all these other kind of native APIs that we usually see in React Native. So, you know, all of these boxes are functions that go from many streams to many streams, and I'm going to make this diagram a little bit more accurate with another transition. Oh, this guy is full of transitions. But this is pretty simple. It's just I feel like you're not going to understand it in the first time, so I need to do it 2 times. I'm just putting boxes inside boxes, okay? Because I have a function call inside a function call. So my app has the tabs view inside it, which has the tabs view. This is rather like familiar as well if you think of how the UI actually looks like. It's rectangles inside rectangles. So this is literally what Cycle.js is. It's data flow unidirectional with functions that take many streams and go to many streams. And I made some drivers for React Native that help me to build real apps. I have some real apps. And the benefits, as we saw, you know, why are we doing this? Is for composability, so we can get all of those components and, you know, make them useful by themselves, not useful tied to the rest. Interception, which is pretty cool for different types of customization of your application, testability, and bottom-up design. I'm going to show you a real-world example of an app that I'm building. It's alpha still, so if it doesn't look great, then don't worry. So I'll start from the innermost component. I have, you know, many components here, but I'm just going to show these 2. The white part is called the public tab, which is a basic news feed, and the outer one is called main, which handles, you know, the blue part and everything else. So how does the public tab look like? We know that it's a function from many streams to many streams. So it does a bunch of stuff in the middle, but what matters is this, that we have many streams to many streams, and it sort of connects those things together. Let's see a little bit in details what we have there. We have sources.screen, okay? What is that? That's basically the event stream of all of the touch events. So if I go some slides back, I can show you. Basically, I had hardware back events, right? So that's a source of events. And it's not software presses, it's hardware presses. So in the same way, software presses are treated in the same style as hardware presses, okay? So that's why I have, oh, now you need to see all the transitions again. But my point is, let's see. Now you need, now all of the software events are handled in this function. That looks pretty simple. What you see there is basically some kind of jQuery kind of backbone thing. I know those are like swear words in this conference, so don't panic. I mean, it's okay. It's okay. Don't panic. You don't need to learn this stuff. And we handle those just in order to like pre-process them a little bit. And then we have the view part, and there, sources.ssb is kind of like my database. So you can think of it as my database data over time, all of the data from now to the future. If we look at how view looks like, it takes that stream of data from the database and sort of maps each feed object to, a public feed component. So what's the public feed? If you look at it, it's just a React component. So you can get the data from the feed thing, and you can put it in a flat list. So now this probably looks familiar to you. You probably feel warm inside, and I feel home. This is good. But then when you see that there's no JSX, you're like, what's that? I'm using something else. Well, sue me. Yeah. So, but the point is that you can use normal React components. You can integrate them. It's not like, this doesn't work with. You need to sort of convert everything. You can just use normal React components. This was the innermost component. How does the parent component looks like? That would be the function main. It's also a function that takes many streams and outputs many streams. And as you can see, I'm calling public tab there, and I'm passing it the many streams as inputs. I also have another tab. And we're sort of, joining streams here, kind of like you join roads, They're just literally sort of the same idea. Then we return many streams. And if you look at the bottom there, I have status bar. So I am controlling the status bar in Android with a stream. And that's pretty cool because it ends up eventually in the singleton that sort of sets the status bar stuff. I don't actually have the imperative calls here. I have them separate, and that's the big point here. How does index.android.js looks like? It basically imports all of those singletons that handle these stuff and gets my main component and sort of plugs those two together, puts them in a loop, and the app starts working. This is literally how short my index.android.js is. So how does the app actually look like? It's a social network. Here you can see peers that are around you, basically local area network or Bluetooth, and then it has news feed, which pretty much looks like Facebook news feed, except this app is intended to be, so you have likes and stuff. It's intended to be decentralized and P2P, so it doesn't spy on your deepest, darkest secrets to make money for Mr. Zuckerberg. It just, all of your data is with you. So it's on GitHub, and you can take a look if you're curious about this architecture. Everything that I'm talking about here is there. It's alpha, but like I'm dedicating 50% of my time for many months to building this. It's serious stuff. This is not the only app I built with this pattern. I also built an app for myself for like taking care of my finances. And I noticed that this pattern is working nicely for me. I haven't seen like serious problems with it and that kind of stuff. Here's a nice bonus. Streams are pretty cool. Not as cool as Ken Wheeler's crossbow, but still kind of cool. You see the line for the status bar there. It's a stream that sends, many colors over time. So I can do something else instead. I'm making their stream periodic 40. What that means is I have a stream of numbers that goes like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, blah, blah. Every 40 seconds it emits, 40 milliseconds it emits a number. And then I can just map each number to a color. So it says lime 0, lime 1, lime 2, blah, 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 lime 9, and then lime 0, lime 1, and etc. And what you get out as an output is a blinking status bar color. Now that was pretty cool because it was done with 2 lines of code, but the lines of code is not actually the coolest part. The coolest part is that this is declarative, okay? Just like component render. And it should be declarative because status bar is UI, right? Why are we dealing with this stuff in an imperative fashion? And yeah. So like imagine, you know, in React we have render, but you can think of the render function as render DOM. Like we should have also render status bar, and then we do it in declarative fashion. We should have render toast, and we do it in declarative fashion. That's sort of what we're doing here. I have a second bonus for you. Okay. You've been seeing this diagram many times today, right? Yeah, you got it. You just replace the names, okay? And then we have the JavaScript engine, or the thread, and we have the native threads, and we have the serialization bridge. What I'm saying here is that this architecture from this framework, Cycle.js, is basically the same architecture that React Native uses. Because in React Native, all of the actual effects happen on the native side, right? And we need to pass messages. So it's a message passing system. And that means that all of the benefits that I listed for you, composability, testability, interception and stuff, could work also here for React Native without, you know, installing these stuff. So just as an idea, you could do like interception stuff. So for instance, all of those events that are being passed through the bridge, such as, you know, the UI manager stuff, what if we would create plugins that would sort of, you know, mutate those stuff? It's just the same like benefits apply in this architecture and the other. There's a lot of things that we could, you know, explore. So the conclusion is basically Cycle is an architecture for UIs that goes beyond just render for DOM. A mobile UI consists actually not of just rectangles on the screen, but also, you know, status bar color, vibration, and all this kind of stuff. And we want to handle those in a declarative style, right? Not just putting a bunch of imperative stuff in action creators. Of course, there's a lot of more things to learn. Streams are not easy, but I'm trying to make them easier because RxJS has like 150 operators, which is like total death in order to learn all of the stuff. So I made a smaller library that has just 20, and you can sort of learn it quite quickly. There's a bunch of other different ideas like Cycle.js isolation, which is like a unique concept for us that does encapsulation. And also the React Native integration with Cycle is rather alpha. It works kind of like React Native worked when it just came out. You know, it works, but of course we can improve it, and we're going to improve it, and that kind of stuff. One cool thing is that I didn't mention the word functional here at any moment. Neither did I mention reactive. So we don't need to talk about those buzzwords if they don't help us at all. But you know, you can use it if you want. You can take some ideas if you want. I just hope that this was inspiration on what's possible in terms of architecture in order to make everything declarative. I also am super interested in bringing all kinds of stuff to React Native, such as Elm. I want to use PureScript for React Native actually, because I have a use case where I need to validate all of the JSON. Because there's no backend, so all of the JSON could be corrupted and nonsense. And actually, PureScript turns out to be a very good use case for that. So that's the type of stuff I want to bring to React Native because I believe it's much bigger than just JavaScript and web. Okay? If you have any further questions, don't feel shy to talk to me. I'm open, and we can go through details. Just come and talk to me, and that's pretty simple. Okay? Thank you.